Okay? And I got inches per second. All right, I'm ready to, oh, wait a minute, hold on. Feet per second. Oh, this is a new trick. Feet per second. I want to get rid of the what's? Get rid of the inches by putting it on the bottom. Cancel, cancel. And putting what on the top? I want to introduce feet into the problem. Now, where do I put what numbers? 1 foot equals 12 inches. There's your conversion. Okay? Most of this is pretty common sense, right? All right. Now, let's see. I can't really reduce this or this. I'll tell you what. You can't have decimals and fractions. Let's go back to one of our new favorite games that we all refer to as Scoot. Thank you. One of our new favorite games, Steve. All right. And the Scoot game, put your finger on the decimals, and how many scoots do we need? 1, 2, 3. We have to get past that 8, don't we? So if you scoot it 3 times, this will be, so what does that become right there?
8.
That would be 8 seconds. What does this become with 3 scoots? 3,200 pi, right? And then over here you have 1 foot and 12 inches. The inches are gone, I guess, on this point, so. Okay, so the only thing left are feet per second. And look at this right here. 8 goes into 32 4 times. So that's going to be 400 pi over 12. And the units would be feet per second. And I'm sure there's something else we can put into 412. You know what? 4 would go into both of those. How about we make this 100? Anyone? Anyone?
For 3.
Okay, over 3. And I'm sure we can't reduce that further. And that's it. Got it? Okay. Now, if this is a problem where they want you to do it in a decimal on the final exam, put the counting things up, just type it in 100 pi divided by 3, enter, you can get a decimal. Okay? If they say leave it as a fraction, you already have it. Okay. We'll do a little calculator warm up for the last chapter of the year, but that's later. Just show you a few tricks. Okay? All right, so far so good? Now again, if you've been in a lot of science classes, you've probably seen a lot of these conversions, so this is really easy for you. But we need to go through it to make sure everybody's on the same page. Okay, now let's go to the clock. Mr. Wade's new clock, which is over there. I still need to get a nail so I can hang that thing up. But the new mathematical clock, Mr. Wade's here, which is a very much appreciated gift from Stephanie, and Stephanie. So when you look at the clock, all right, every clock has a certain measure for the minute hand, the hour hand. Okay, we will assume, we should know, that the shorter hand is always the hour hand, since it's a very strange clock. So the short one is the hour hand, the longer one is the minute hand, and then of course the red one, that would be your second hand, right? Okay, so we're going to figure out, I measured that clock over there, and the clock measured to be 11 centimeters for the minute hand. All right, so you make this a real life example. All right, so that measures 11 centimeters. Now, here's the trick in this question. It is a minute hand. And the minute hand is actually going to act as a what?
Diameter.
It's a radius.
It's only a radius, and it only goes from the middle to the edge. Okay? Mr. Wade, you didn't tell us how big the whole clock was. Guess what? You don't have to have the size of the whole clock. It doesn't matter. What matters is that the tip of the minute hand, won't the tip of the minute hand make its own circle that's smaller than the clock? Okay? So all we need is that right there. And this is a, so note it right now. Write down radius, because that is very important, not diameter, right? Okay? All right, so radius. Now then we'll have to convert it. Okay, we're going to find out how far it travels in 20 minutes. Okay, so first things first, what do we find? Find the circumference. Okay? That's a common theme of the day, isn't it? All right. Now, when you find the circumference formula is what? Okay? It's either d pi or 2 pi times radius. So you have to double the radius and make it a diameter, and you get what? 22 pi. And what does this end? Centimeters. And that is your circumference that the tip of the minute hand creates. Okay? And of course, again, the tip is going faster than the inside. All right, so we got that. Okay, now let's see what else we have here. We have to figure out how far it travels in 20 minutes. All right, so distance traveled. Okay? Now here's the thing. How long does it take to do the full circumference for a minute hand? All the way around to the same place. That is 60 minutes. So I don't have to give that to you, that's assumed on every clock. So that is the traveling in 60 minutes. But I want to find out 20 minutes, what it would be, what fraction of that?
1/3.
That would be 1/3 of the circumference, okay? Now, if you want to write this in your notes to remember where the 1/3 came from, it's 20 minutes out of 60 minutes times the circumference in centimeters. And actually, the minutes and minutes will cancel each other out, and you'll just get 1/3 of 22 pi centimeters, and that makes 22/3 pi. Now, every other problem today, we got per second, per minute. Why didn't we get that this time? We lost our minutes. We just got, oh yeah, it's distance, so it's in terms of centimeters, right? It's not moving, it's not what velocity, it's not centimeters per second. It's just centimeters, measured. Okay? And there's your answer. All right, now, next part. How fast does the tip of that hand on that clock over there move in centimeters per second? We can figure that out. But on a clock, you have to interpret, because it's not all spelled out in the paragraph there for you. If it is a minute hand, it makes one what? What's that called?
Revolution.
Revolution per 60 minutes. So in F, we have one revolution per 60 minutes. Okay? That we know for any minute hand, right? Clock's not broken. All right? So you get that right there. Now, we also know what the circumference is, don't we? Isn't the word revolution the same thing as circumference? And we can plug that in there. Okay, this is on camera. Be quiet in the studio audience there. All right. Now, yeah, quiet. That's exactly right. This is in centimeters per second. What do I need to put in the problem? The only thing I'm missing right now. I need seconds in the problem. Tell you what, let's go ahead and put that in there. So I need to put what on top? 1 minute on top. And on the bottom? 60 seconds. Minutes cancel. Ah, there it is. 22 pi over, oh my gosh, 60 times 60. Well, the only thing we can reduce would probably be this. Let's reduce this. What is 22 over 60? 11 pi over 30, and that's about all we got. And that's in centimeters times 60 seconds. So you can reduce at least one thing. And then is there any more reducing here at all? Okay, 11 is a what kind of number? A prime number, so there's nothing else to reduce. So we get a strange looking answer, but it's real life. It's 11 pi over 3 times 6 is 18 with 2 zeros. And that is in what? Centimeters per second. And that is a very small number, but for good reason. If you actually watched a minute hand go around for an hour, wouldn't it be moving pretty slowly? It would be very painful to sit there for an hour and watch that without looking away. Okay, very small number, makes sense. Okay. Oh my gosh. We got this, no problem. Actually, yeah, the last 3 are really easy. Okay. So, for the next one, we have the most expensive bicycle in the entire world.
Do
you have one?
No, I do not have one of these. Very funny.
Yeah,
But they look nice.
Keep going.
But it's $34,000. Who wants to spend that much on a bicycle? Unless you have money to burn, right? I don't.
34,000.
Okay, $34,000 for this bicycle right here.
Oh,
All right, that's a lot of money. Okay, so first of all, we're going to find the area of each circular sector of the wheel. All right. So let's draw this out here. Okay. CQ. Okay. Find the area of each circular sector. What in the world is a circular sector? It's a slice of pie. That's what it is. Slice of pizza. Okay? The reason it says, it's going to make me hungry for pizza now. The reason it says circular sector, that's to prevent you from making a pizza that's an ellipse and then cutting out a slice, because that'd be a lot more complicated. We won't do those. Okay? This is a perfect circle, and then that's a circular sector, not an elliptical sector. All right? A little tricky. Okay, so in a circle, if you take a sector, it's just a certain percentage of the entire area, isn't it? All right? All right, for the first time today, we are not going to do circumference first. We're going to do the what of the circle first? The area, because we're looking for the area of that slice of pie right there. Okay? Now, if you want to find the area, sorry, I lost something there. All right? If you want to find the area of a pizza, a circle, now I'm getting hungry, of a circle, it is what formula? Pi radius squared. Okay? That's one of our old favorite formulas, right? So, we're going to take that and figure out the size of this entire bicycle tire right here. And what do we plug in for the radius? 24. Mr. Wave Lucky number. All right? Now, if we plug that in, you probably don't know 24 squared off the top of your head.
576.
It is 576. I'm impressed. I'm very impressed. All right? Luckily, you won't have to know that that's 576. You can multiply that the long way, or just keep it 24 squared. I'm going to show you the shortcut. All right? Watch this. Okay, so that's the area. But I want the area of just that sector right there. Sector area. How can I find out what percentage of the entire circle this slice is right here? You probably did this in geometry, actually. Wait a minute. 45 degrees, that's probably a big hint right there. Isn't it 45 out of 360, right?